We're solving problem 22 from the 2020 F equals MA exam A. A collision occurs between two masses. In each internal reference frame, one can compute the charge and total momentum, change delta P, and change in total kinetic energy, delta K, due to the collision. Which of the following is true? A. Delta P and delta K do not depend on the frame. B. Delta P and delta K do not depend on the frame for perfectly elastic collisions, but P may depend on the frame for inelastic ones. C. Delta P and delta K do not depend on the frame for perfectly elastic collisions, but K may depend on the frame for inelastic ones. D. Delta P and delta K do not depend on the frame for perfectly elastic collisions, but both may depend on the frame for inelastic collisions. And E. Delta P and delta K may both depend on the frame for both perfectly elastic and inelastic collisions. So in this problem, we want momentum to be conserved. So therefore, our change in P is going to be 0. We can say that our initial kinetic energy, K initial, these two masses, basically they're just their kinetic energy summed up. So this is 1/2 m1 v1 squared plus 1/2 m2 v2 squared. Then we can say that kinetic energy final is 1/2 m1 v1 squared final. Where this basically denotes that it's the final velocity after the collision. And then this is 1/2 m2 v2 squared f. Now the reason why we don't apply the final mass to both of these objects is because the mass do not change in these collisions. We can then say that the change in kinetic energy is the subtraction of these two. So we factor out 1/2 m, the mass from both of them, to get that this is v1 f squared minus v1 squared plus 1/2 m2 v2 f squared minus v2 squared. We can use difference of squares to factor this out. So once we do that, this is 1/2 m1 v1 final plus v1 times v1f minus v1, and then same goes for the second mass. So this is 1/2 m2 v2f plus v2 times v2f minus v2. So we see here that the subtraction of the velocities is the change in momentum for each case. Therefore, this delta K can be simplified down to 1/2 delta momentum, change in momentum 1 times v1f plus v1. And then we can do that for the other one, plus 1/2 delta P2 momentum to then this would be v2 final plus v2. Now, since we denote that the potential energy 1 is equal to negative potential energy 2, change in negative potential energy 2, we set that as our potential energy or momentum in this problem. Since these are negatives, we simply just factor them out. So delta K is 1/2 delta P1, change in momentum, v1f plus v1 minus v2f minus v2. This is because in this problem we set momentum 2 or momentum 1 to be equal to negative change in momentum 2. So therefore, this is our final equation for our kinetic energy, where we see that in this case, the change in K and change in P do not depend on the frame. Therefore, answer choice A is going to be our desired answer for this problem.